Calcium deficiency can cause osteoporosis, weakening of the bones. The minimum amount of calcium in 1 milliliter of blood should be around 1.3 times 10 to the 18th atoms. A patient has her blood tested and the lab finds there are 3 times 10 to the minus 5th moles of calcium in the blood. Is this patient at risk? Well, if you click on this, well, first try and work it yourself. And you can pause this video if you need to. And when you're done, okay, let's just click here. So we do the calculation. Here's Avogadro's number, 6.02 times 10 to the 23rd atoms per mole times the number of moles that the lab technician found out. Just notice the unit cancellation here. We have atoms per mole. And let's try and make that all a little better. The S. Times moles. What's that going to give you? Number of atoms, okay? So we carry that out and we find 1.8 times 10 to the 23rd atoms of calcium, which is much greater than that, so the patient is just fine. In order to do calculations involving ionic and molecular compounds, we're just going to have a quick review here. The total number of atoms or ions in a compound depends on electronegativity and bonding. So here's ionic compounds. Sodium chloride, we have 1 sodium ion, 1 chlorine ion. Potassium chromate, 2 potassium ions, and you see the plus there for the potassium. 1 chromate, CrO4, 2 minus. And then tin hydroxide. And what we have here is 1 tin ion, and we have 2 OH minus ions. Molecular compounds, covalent compounds, water, 2 hydrogen atoms, 1 oxygen atom, C6H6, 6 carbon atoms, 6 hydrogen atoms. So over on the left side, we're talking about ions. The right side, we're talking about atoms. Chemicals are composed of more than one molecule or formula unit. And remember, molecule forms molecular compounds or covalent compounds. Formula unit is ionic compounds. To indicate more than one molecule or formula unit, add a coefficient in front of the compound. Coefficients are integers, 1, 2, 3, 4, 5, 6, etc. So right here, we have 6 molecules of carbon dioxide. You can count them. How many atoms of carbon and oxygen are in 6 carbon dioxide molecules? Well, you can either count each one or just use this guy. And carbon, you multiply the 6 times 1 carbon, you get 6 carbon atoms. And for oxygen, 6 times 2, because there's 2 atoms in the molecule, 6 times 2 is 12. So let's fill in the blanks here. We'll start with the ionic compounds. And the first one was done for us. And notice they just multiplied the coefficient times however many atoms were there. So here for potassium plus, 2 times 2, 4. And the ion here, the chromate ion, there's only one of them inside the ionic compound, so 2 times that whole configuration there is just 2. Here, 410 hydroxide, well, there's 4, but there's 2 of them in the ionic compound. 4 times 2, 8. Let's go over to water. Hydrogen, 6 times 2, 12. Oxygen, 6 times 1, 6. C6H6, well, there's a 1 in front of it. You're assuming a 1 if there's no other number there. So we have 6 carbon atoms, 6 hydrogen atoms. Now we're going to convert moles to the number of particles we have. So recall, when we had 1 molecule of water, 18 AMU, in 1 mole of water, which is 18 grams, we had 6.02 times 10 to the 23rd water molecules. So in 1 mole of water molecules we have, this number here tells us that we have 2 moles of hydrogen atoms and then 1 mole of oxygen atom. Here, let me kind of rewrote over that. So 2 moles of hydrogen, 1 of oxygen. So to find out how many atoms there are, we multiply that by Avogadro's number. So this tells us how many atoms of hydrogen we have, and this tells us how many atoms of oxygen. Let's take an ionic compound Same drill. If we have 3 moles of sodium chloride, and remember, formula units are what we use for the ionic compounds, there's our 3, that tells us that we have 3 moles of sodium plus ions and 3 moles of chlorine minus ions.